going to determine the frictional force of a sliding beanbag using Newton's second law. From that frictional force, we can calculate the coefficient of friction between the beanbag and the floor. Our question, we're trying to figure out if an object in motion stays in motion, then why does the sliding beanbag come to a stop? Sir Isaac Newton was one of the greatest scientists and mathematicians that ever lived. He was born in England on December 25th, 1643. He lived for 85 years. Newton's first law is an object at rest will stay at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This means that if there is a natural tendency of an object to keep on doing what they're doing, all objects resist changes in their state of motion. In absence of an unbalanced force, an object in motion will maintain this state of motion. Newton's second law states that acceleration is produced when an unbalanced force acts on a mass. The greater the mass of an object being accelerated, the greater the amount of force needed to accelerate the object. Everyone knows that heavier objects require more force to move the same distance than lighter objects. His accomplishments laid the foundation for modern science and revolutionized the world. Isaac Newton died in 1727.
For this experiment, we needed a scale, a stopwatch, beanbag, tape, and a meter stick. To do the experiment, we threw the beanbag at a strip of tape on the ground and timed how long it slides.
131.
After that, we measured the distance between the beanbag and the line and recorded the data. We repeated this 3 times and averaged the results.
So for our calculations, we started with trying to find the VI of our beanbag trying to slide across the floor. So we took the distance as delta x. We used 0.5 just as a thrown in number. For the formula, we used our VF was 0 and our time was 1.32. And we took all that, we did the math, we divided 0.5 by 3.95, and then we divided 1.32 divided by the number that came out of these two, and we got our VI as 5.98. We took the VI, we added it to this formula where our VF was still 0 equals VI of 5.98 plus the acceleration times the t for time, and then that gave us the acceleration as 4.53.
And to find F net, we did mass times acceleration, which is 0.7995 times 4.53, and got an F net of 3.62 newtons. We then took the 3.62 to find the coefficient of friction, and to find that we did acceleration equals mu times Fn, and Fn being 7.835. And then we just solved it and got a mu of 0.462.
Results, we got a mu of 0.462, which seems about right when the beanbag weighs 0.799 kilograms, and we averaged 1.32 seconds for each toss. We used the frictional force formula to find the friction between the floor and the beanbag. The frictional force is a force that is created whenever two surfaces move or try to move across each other. The friction always opposes the motion or attempted motion of one surface across another surface. Friction is dependent on the texture of both surfaces.